Okay, this is 3.1, solving one-step equations, and this is short and sweet as well because I need you already to be at a place where this is quick and easy. So we're just going to do a little refresher here of basically 3.1 and 3.2, and then we're on our way. So for example, here's a one-step equation. You can obviously tell just by glancing at it what x is, right? What number plus 7 is 4? Oops, can you? We better check it. So do you remember this from last year? This is like a balance scale. I have 7 that I have here, and I have to get rid of it. X needs to be by itself. Well, if I have 7 of something, I'm going to take away 7, but whatever I do on one side, I have to, that's right, do to the other. So on this side, 7 minus 7 cancels, or I have 7 positives and 7 negatives. They cancel. X equals 4 minus 7 or 4 plus negative 7. Your choice how you want to think about it. This needs to be an automatic in your brain. It's x equals negative 3. And then what we did is we checked these answers last year. So x we think is negative 3. Negative 3 plus 7 equals with your question mark over it. Is that 4? So negative 3 plus 7, yep, it's 4. 4 equals 4. Check it off. All right, so the next guy over here is a subtraction problem. Go ahead and do it, and then check and see if you've got the right answer. You can pause it. We add 12 to both sides. X equals 15. We have our check. 15 minus 12, does that equal 3? Yep, it does. Okay. The next one is a multiplication problem. So how do we undo multiplication? We divide. All right, so in this problem, we undo multiplication by division. And so we're going to divide. But what are we going to divide by? If we divide by regular old 6, negative 6 divided by positive 6 is a negative 1. And we don't want a negative 1x. We want it to be a positive x. So you have to divide by that exact same number. And whatever I do to one side, I do to the other. So x equals negative 8, because a positive divided by a negative is a negative. And we stick it back in the original to check. So negative 6 times negative 8. Is that a positive 48? It sure is, because a negative times a negative is a positive. Okay. My last example of one steps over here, x divided by 4 equals 20. The opposite of division is multiplication. So we're going to multiply both sides by 4. So x equals 80. And we have our check. And guess what? That is all the time I'm spending. You're going to have a little bit of practice on one-steppers, but that's it, baby. We're moving on. So hopefully that was quick and easy for you. If you have any questions, certainly see Mrs. Wyman. You know what? I lied. I'm going to stick one more in here. I know you did these last year, but I want to do one more. Negative x divided by 2 equals 4. This is kind of a one-stepper, kind of a two-stepper. You can think of it either way. I need to get rid of dividing by 2. So I'm going to multiply both sides by 2, but that negative is still stuck up there, so that poses a teensy bit of a problem, because I don't want to know what negative x is. Another way to rewrite this same thing would be negative 1x equals 8. So really what you could do at this step is divide by negative 1, and x is going to be negative 8. If you don't want to think of it that way, you can also think of what is the opposite of negative x. It's x. But whatever I do to one side, I have to do to the other. So x is negative 8. To check it, when I plug it back in, it's going to be a negative times x. And x is negative 8, remember? So I actually have a negative, negative. So I use parentheses there to separate. Equals with your question mark. Divided by 2 is 4. That's the original problem. And a negative times a negative is a positive. This is like negative 1 out there. So it's negative 1 times negative 8. 4 equals 4, so I know I did it right. Okay, now we're done with 3.1 notes, and we're going to go on to 3.2 right now. If you need another piece of paper, that's fine, or you can just continue on. So here we have 3.2, solving two-step equation notes, and we're going to start off with our very first one here, which is going to be x over 2 plus 5 equals 11. So this is a two-step equation. Which one do we get rid of first, division or addition? Well, remember, we always go backwards in order of operations here, so we have to get rid of addition first. We subtract 5 to both numbers. This is our balanced scale here, remember. So whatever I do to one side, I have to do to the other. I don't do to the x over 2. It's already on this side of the balanced scale. Okay, so once I subtract 5, I'm left with x over 2 equals 6. And now we're back to a one-step equation. Multiply both sides by 2, x equals 12. Okay, and we're going to check it by plugging it back into the original. 12 divided by 2 plus 5 equals question 11. 12 divided by 2 is 6. 6 plus 5 is 11. So 11 equals 11. It checks out. Alrighty. So number 2, I've switched it up a little bit here. I have actually put two variables into the same problem. Are they like terms? They sure are. They make 3x when you subtract, or you could say adding a negative. Either way works. So that's a 3x that way. 3x equals 21. Divide both sides by 3. X equals 7. To check my work, it goes in for both x's now. So 7 times 7 plus negative 4, you could have kept it as a minus, times 7 equals question 21. 7 times 7 is 49. Negative 4 times 7 is negative 28. And if I do a little subtraction here, yep, that's 21. And you need to do the check. Don't just say, oh, I'm sure it works, because that's when you don't catch a mistake. So I did the check there in my brain to make sure that it was 21. All right, the next guy kind of ran into my check here. It's 11 minus x divided by 2 equals 60. So we need to get rid of 11 first. Is this 11 a positive number or a negative number? Who cares what this is? What is the 11? It's positive. So we have to get rid of positive 11 by subtracting or adding a negative 11. Then we're left with negative x over 2 equals 49. And now we're kind of like the last one that I did on 3-1. So we're going to get rid of dividing by 2 first. So negative x equals 98. And then you can put a 1 in front and divide both sides by negative 1, or just say what's the opposite of negative x? It's x. What's the opposite of 98? Negative 98. And then we're going to check that guy. Okay. So it's 11 minus negative 98 divided by 2. And the book will usually put parentheses around it when you have a minus sign and a negative sign next to each other so they don't blend in. Is that equal to 60? So I need to divide by order of operations first. So a negative 98 divided by 2 is 49, negative 49, right? Equals question 60. And then here I have a minus a negative becomes plus a positive, which is 60. Okay, so that guy works. So the last thing I want to remind you about was something we've already talked about this year, a little teeny bit. So if I have the fraction 1/2, we know that's equivalent to 0.5 or 50%. But what if I had a negative half this way? That's a negative 1 over 2. It's still a negative 0.5, right? Is that the same as this? 1 over negative 2 that way? Well, what decimal is that equal to? A negative 0.5. So those are the same whether the negative's on top or on bottom. But what if I put it out front? A negative half that way. Well, what decimal does that equal? A negative 0.5. So those all are the same thing. So when I have the number out in front, the negative sign or the subtraction sign, I can rewrite it on top or on bottom. I could have stuck it with the negative 2 right here and made my life a whole lot easier and just multiplied both sides by negative 2 right away. Okay, so that's the end of your notes. You're going to continue on with your work, your practice from, 3-1 and 3-2.